Good morning, everyone. My name is Carlos Souza, and it's a pleasure to be here. This is my second time at All Things Open. I was here last year as well, and it's always a great time to come here and talk to you all and see what's happening in the world of open source, talk with contributors and whatnot. There's a lot of great talks happening right now, so thank you all for being here, and hopefully I can live up to the expectations. Just so I know, anyone here actually works with Rails on day-to-day? Cool, awesome. All right, so a little bit about me. I work for Code School. We are an interactive platform for teaching web technologies. We're a small company down in Orlando, Florida, and we specialize in teaching web stuff like Ruby, Rails, JavaScript, some of GitHub as well, HTML, CSS. This is an example of one of our courses, tryruby.org. This one specifically is free. You can try it out. It's a great way to show Ruby to your friends. They can just go up to the website and have fun, hopefully. This is another example. This course teaches Rails. Again, this is another free course. Any of you heard of Rails for Zombies before? Cool, nice, awesome. All right, enough about me. So I'm going to be talking to you today about is how to build better web APIs with Rails. But before we do that, I want you to try and picture the following scenario, right? The perfect Rails web app. It was delivered in the deadline, so your team were able to meet the deadline, deliver the project when it was supposed to your client, or if it's an internal project. It was developed within budget, so you didn't spend any more money than you had to or that your client had available. It included all the features that were planned initially. So the client was pretty happy with it, and it had enough tests. Not too much, not too little, enough to get you confidence to deploy to production and whatnot. So this is what I like to call the perfect Rails web app. Now, your client comes to you and he says something like that. We need a snappier experience. And usually when they say snappy, they clap their fingers like that. So we need a snappier experience. And what this usually means is that they're looking for something more JavaScripty on the front end side of things, perhaps using a JavaScript framework like Angular, Ember, Backbone, Knockout, whatnot. Or they might say something like this. So it was detected that the majority of the visitors actually use the website from their mobile phones, from their tablets. And now, your client is looking to launch a native app, right? And these are all reasonable arguments, right? Especially if you follow the agile techniques, agile principle, and lean, you embrace change, right? Change is good. This is something positive that we want to hear from our clients, right? This is positive feedback because it gives us sort of a direction to where to go next, right? So naturally after this, the next question is, does a web app expose an API, right? And when talking about Rails, the answer is usually kind of, because it's really hard to build Rails web apps that don't expose some sort of API. But today I want to talk about 5 things that we have to look at and be very careful and can help us answer the question and say, yes, our application does have an API, and we can support different types of clients, and we can scale accordingly, and we can quickly adapt to future changes. So this is what we're going to be talking about today. So let's jump right in. First, we're going to start with routes. So routes in Rails is the way that Rails maps URLs to controller actions, right? They're the endpoint of your application. And speaking of URLs, URLs are extremely important, especially when talking about APIs. Defining URLs that are intuitive, it's helpful for API developers and for consumers at the same time. They convey intent, and they provide a certain level of documentation. Let's take GitHub's API, for example. If we look at the following URL path, /gists, right? We don't have to look up documentation to figure out what this returns, what this does. Naturally, it's going to return your gists, right? Assume you're making authenticated API calls. And it's also common to use to represent filters or subsets in URLs. For example, /gist/public, right? Again, you don't have to look up documentation to figure out that this returns only the public gists. And the same thing for start, right? /gist/start. This is going to return all your gists that were start. Now, back in 2006, DHH, the creator of Rails, brought into Rails a feature from the Simply RESTful plugin. This was a couple years before I even started working with Rails, but I do remember that with this plugin, what this feature provided, was really attractive to me as a developer. So what this does, it allows us to talk in a higher level of abstraction. So we would no longer need, in a routes file, to declare individual URLs for get and post and delete and whatever. We would just be able to talk about resources, right? So the feature evolved, and this is what it looks like today in Rails 4, right? We create our resources for projects, and what it gives us is a couple different things. It gives us these URLs that we can work with, /projects for all the projects, and for specific project, /projects/ID. And these are the ones that matter for us when talking about API. And it gives us all these methods, and combining the paths with the methods, we can create mappings for all of these controller actions, right? Which is basically CRUD. We can create, we can retrieve, we can update, and we can delete our resources. But how about if we wanted to extend our URLs to look something a little closer to that GitHub example that we just saw? What if we wanted a URL that would return all the archived projects and another URL that would allow us to archive a specific project? How can we do that with Rails? The answer is using the member and the collection methods, and this is what it looks like. First, the collection is going to act on all your projects. So when you pass a block to the collection, you say that you want to expose the archived URL, which is nested under projects, and that it accepts GET requests. The same thing for the member. Now, you want to expose a /archive URL that takes post requests and act on member projects, so /project/ID/archive. And this is not inherently bad. This is okay. The problem is when you start abusing this feature, right? When you start adding more and more extensions to your resources, right? And the problem with that is that each one of these, they are translated into methods, into actions in your controllers. So the next time that you open up, this is the same controller, by the way. This is the project controller. So the problem is the next time you open the project's controller file, it's probably going to have a couple hundred lines. And this is bad, right? I mean, if you've been programming for long enough, you know that long files are not a good thing, especially when a lot of people are editing them at the same time. It can turn into all sorts of conflicts, and yeah, we definitely want to avoid that. And the good news is that it's really easy to work around this issue in Rails. So there is a way to both have friendly and intuitive URLs and organized code. All we have to do in this file is to pass one option, the to option, right? What the to option does is it routes that URL that you've defined to a specific controller action. So in our first example, we want archived not to be an action in the project's controller, but to route to the index action in your archived project's controller. The same thing for active and suspended. Now they get their own controllers. For the member routes, we do the same thing, but now we route to the create actions in each of those controllers. Another benefit that we get, not only we clean up our project's controller file, but we also go back to only working with the default actions for controllers. We go back to only talking about the CRUD operations. So when we're talking about getting all the archived projects, we're talking about retrieving all the archived projects from the archived projects controller and not one specific action on the project controller anymore. This makes it a lot easier for a team to work within a code base, because now if you want to do something, if you want to update a feature, if you want to do something to the archived projects, you have one file that you go to, right? You don't have to open up your long projects controller file. But how about that post? Let me use my pointer. But how about that post create review here at the bottom? What can we do that? Well, it's a good candidate for being extracted into its own resource now that's nested under projects. But before, we were only interested in creating reviews. Now, we're allowing people to do everything with reviews, because the resources method exposes all the endpoints for creating, deleting, updating, and whatnot. If we want to be really specific about what we want to expose, we can use the only function, passing in the only action that we want to allow this resource to expose. And if you have a routes file that has a lot of resources, when you limit the actions that you want to expose on those resources, you make the whole routing system faster. One last thing to talk about in routing. If you're namespacing your API controllers, you're probably used to seeing something like this, right? You create a namespace in your routes file, which causes all your controllers to be namespaced within a module. But Rails' camel case feature forces you to write API like that, right? So capital A, lowercase p, lowercase I. If you're a little OCD like I am, this is going to wake you up in the middle of the night, right? You're not going to be able to breathe. So again, another very easy thing to fix. If you look at this inflections file, which is an initializer, Rails creates automatically for you, you can add an entry for acronyms like API. And what this will do is this will tell Rails to skip any automatic camel case parsing on this specific string, so you can go back to using all uppercase API, and now you can breathe. That's it for routes. Now I'm going to talk about content negotiation. So content negotiation is a process where the client and the server determine what the best representation, what the best format is when we have many available. In this example, we have client A, that's a rich JavaScript application, jQuery, Angular, Ember, Backbone, whatever. And it's asking for JSON from the API server. Now we have client B, which is an enterprise application and wants XML. Haha, business. Lastly, we have client C, which is a browser, and it's asking not only for HTML, but for HTML in Spanish. So content negotiation is figuring out how to respond to different formats from the same API server. Now Rails, from a client request, Rails accepts two types of content negotiation styles. So the first one is by using a file extension. You can see here up at the top, we're asking for the JSON format on /projects.json. Another way is by using request headers. In the example at the bottom, we're passing a custom accept header saying that our client accepts application/JSON format. Now, both of these are supported by Rails out of the box. The problem is that the first one is just a nicety, right? It goes back to supporting old applications that used to map URLs to individual files, which is hardly the case in applications today. But the one on the bottom, which uses request headers, this is actually part of the spec. This is what API clients should be relying on. From a developer perspective, writing Rails apps you don't have to worry about these too much because Rails automatically picks up these two formats for you. Let's look at the syntax. First one is using responders. This was a feature that was brought in from an external gem, a couple of version of Rails, and now on upcoming Rails 4.2 is going to be extracted out to a gem again. But this is what the syntax looks like. We call the respond to method at the top of our controller, specifying the formats that our controller understands. And the order matters, because if the client doesn't specify one format, Rails is just going to use the first one in the list. So in this case, JSON. Now, from each of our actions, we can call the respond with method. And this method is going to be able to figure out what format the client was expecting, is asking, and respond accordingly. Another way is to use the respond to, but not as a class method anymore, but an instance method. So we call the respond to from inside of our controller action. We give it a block, and then inside of our block, we can call the methods according to the formats that we accept. So you can see the first one is JSON, the second one is XML. Rails comes with support, last I checked, for 22 different media types. So there's 22 different methods that you can call on the format object that Rails knows how to respond with automatically. And because we're passing in our projects as an argument to the render JSON in there, what it's doing, it's calling to JSON on those models behind the scenes, right? So if you want to customize the way that you serialize your objects, you have to implement and override the toJSON method on your models. Now, that can lead to messy code. And that's why, again, Rails provides you with another way that you can customize your serialization, and it's called Jbuilder. This is a gem that comes as part of your gem file, uncommented. So every time you run a scaffold, Rails will automatically generate the Jbuilder file for you for the specific model that you've created. This is what the Jbuilder syntax looks like. I copied this from the official README, right? Syntax might feel a little weird if you're used to working with the object-oriented paradigm in all other parts of your application. Then you get to your serialization part, and then you have to learn this kind of funky syntax. The good side is, again, it's part of Rails, core. So you have the support from the Rails team. But there are alternatives. First, there's Activemodel Serializers. And this is what the syntax looks like. So you can see it's a little bit more OO. Syntax is not that hard to understand. It's just classes and method. And it comes by default with support for the JSON API format. The maintainers and authors for Activemodel Serializers are also part of the Ember team. So they were able to make Ember talk with Rails applications that use Activemodel Serializers in an easy way, right? So if you have a Rails app and you use Activemodel Serializers, and then you have an existing Ember.js application, you can use the, forgot the name now, so REST adapter, the Activemodel adapter on your Ember.js application, and things will just magically work. So this is a good thing. And as you can see, first thing we do is declare that we define the attributes that we want to serialize. In our example, we are serializing ID, title, and amount from our projects. And then down at the bottom, we're specifying the relationship, just like we do in Active Record has many products. And when we say embed IDs include true, what this does is a thing called side loading. So it's going to fetch the IDs for your products, and it's going to include them in an array inside of your project's object, inside of your project's hash in JavaScript. And outside of that hash is going to bring all the products. So next time that your Ember application or whatever other JavaScript client you're using needs to look up the associations, it's not going to have to go and make additional HTTP calls. right? So the side loading feature is really cool, and it prevents from additional HTTP and unnecessary HTTP calls from your client. Activemodel Serializers is a really cool project. I've used a lot, but right now it's going through a transition period. It's going through a major rewrite. So if you choose to use it, make sure you check out the mailing list and the GitHub repository to know what's coming ahead. And the project needs help. The lead maintainer for this project is Steve Klabnik. He is speaking later today. He's also the maintainer for various other projects, and he's a super cool dude, and he's just rewriting this whole thing from scratch. So if you run into any problems with this, make sure to contact Steve, file an issue. He's a super cool guy. He's definitely going to be able to help you out. Finally, another alternative is called Roar. This is a recently new project, and it kind of combines the OO approach with some of the features from Ruby, like mixins. And there's two ways you can work with Roar in Rails. You can either use it as a form of mixin, which is the format on the left. So you declare a module, you declare how you want the serialization to happen, and notice we're using the JSON API format at the top, and then you mix that module in whatever class, right? It could be your active record class, it could be another pure Ruby object, doesn't matter. Or if you want, you can use the other format on the right, which is called the decorators. So you create a serializer class, a representer, which is what Roar calls it, and then you inherit from Roar decorator. The syntax looks very similar, but now it's inside of a class and not a module. So I'll definitely recommend checking it out. Cool, that's it for content negotiation. Let's briefly talk about authentication. We're going to look at two strategies that Rails supports out of the box. One is quicker, the other one's a little bit more robust. So the first one is HTTP basic auth. You all should be familiar with it. It's been around forever. It's quick and simple because it requires a username and password on the authentication process. So what a lot of people do, what a lot of developers do, is they simply reutilize on the API side the credentials used on the website, which kind of helps you get quickly going, although not ideal. And it's also part of the HTTP spec. And every time that you come across a feature that's part of the spec, you can kind of see it as a seal of approval, because you know that clients that follow the spec are likely to implement that feature correctly. But there are alternative ways that you can use it in Rails, but let's look at the supported out of the box. So first we have a project controller, and at the top we have a before action, which is the same thing as a before filter, which is just renamed in Rails 4. Now we're calling the authenticator request, and inside of that method we call this long function, authenticate or request with HTTP basic. Again, this function is part of Rails. And then that function automatically reads the credentials from the request, and we can use that in our own authentication code, which in this case is user.authenticate. So if that returns true, the process continues. If that returns false or nil, the request is halted, and the user gets a forbidden response. One way to test that with curl is by using the -u option. So I highly recommend knowing how to use curl when developing an API, because it's the quickest and easiest way to test your application manually and debug it, right? I use it a lot. There are graphical clients, but a lot of the ones that I've seen, they're simply built on top of curl. So there's nothing you can't do with curl that you can do with those clients, pretty much. So here we're using the -u option and passing the username and password separated by colon, accessing that specific URL, and then we can see at the top we get a successful response. Another way to do it is by passing the username and password as part of the URL, which you might have used in browser clients to access HTTP basic auth protected resources. So that's the benefit, another benefit of this. If you have an API that implements basic auth, you can simply access it with a URL using the username and credentials. Another strategy for authentication is token-based auth. One of the benefits is that by using a token and not reutilizing user credentials from the actual website, you can expire or regenerate tokens. So you have a little bit more control over the access on your API. And any vulnerability, any flaws on the API tokens are limited to the API. So if someone gets access to the token, they can't log in through the user's account on the website. They only have, the access is restricted to the API. You can generate multiple tokens for each user if you need a little bit more granularity and control over what resources they have access to, and different rules can be implemented. Now, to provide the token, we typically make it available on out-of-band, which is what we call, it's not part of the API process. It's not part of like HTTP calls to your API. You actually have to go through other trusted sources, which usually involve going to your settings on the specific service's website, like we see here. This is an example using Backpack, which is a service by 37 Signals. So you go to your profile in Backpack, and then you have access to the token, API token that you can use on your requests. What some services do as a security feature is that they will only display that token once. This is an example from DigitalOcean. If you go to your DigitalOcean profile and you need access to an API token, they're only going to show it once. If you need to see it again, you're going to have to delete that token and create a new one. So let's look how we can use token-based auth from Rails. Again, it's built in right out of the box. This is the same code that we had before, but now instead of using the HTTP basic auth, we're using the token, authenticate or request with HTTP token, which looks at the request from the client, grabs that token, passes it in as an option to the block, and then you can use it to implement your authentication. Now, to generate tokens from the API server, we're going to use a thing called Uuid, which is Universally Unique Identifier. Again, it's part of the HTTP spec. It's got its own RFC, so we know we can kind of trust it. And what the Uuid is just a big, long token that's guaranteed to be unique across a global namespace. Now, to generate a Uuid in Rails or in Ruby, we can simply use the Ruby standard library. We don't have to install any gem. It comes built into the language. So secure random is the class, and Uuid is the class method that we call, and it's going to generate Uuid tokens for us. Now, how can we use that from our Rails application? Here's a very simple example. We're going to use that class and that method, and we're going to make it part of our user model. So every time that we create a new user, the before create callback is going to be run, and it's going to check to see if the token is already present. It's going to return, right, guard clause. We don't want to overwrite whatever was said. Especially, this is especially useful for tests, for unit tests. Sometimes you want to inject the token as an argument, so if you inject it, you don't want it to be overridden. So first thing we do is we check to see if it's present or not. If not, then we generate a new one. We call the generate auth token method that calls that secure random Uuid. But if you remember, the token that's generated by that method has dashes in it, which might not be friendly for URLs and other means. So let's go ahead and just gsub that dash with empty space. So we're going to remove the dash, the hyphens, and we're going to have a friendlier token to use. By the way, this is one of the few scenarios that I recommend using active record callbacks, because we're only dealing with the project's own properties. Every time that you find yourself using active record callbacks and you're calling out to other classes, take a step back, take a moment to see if there's other ways to do it. Now, how do we test token-based auth from curl? We use the -H option, which tells that we're sending a custom request header. And this is what the request header for the token authentication looks like. So authorization : followed by token, and then token with the actual value for it. And we see we get back a 200 successful response back. Now we're going to talk about versioning. When it comes to versioning, you might have heard about something called semantic versioning, SEMver. Now, semantic versioning is great. I highly recommend that you follow it for software libraries. What semantic versioning tells you is that major versions, they should be bumped whenever there's incompatible changes. So if 2.0 is the current version and we add incompatible changes, we bumped it up to 3.0. Now, minor versions are used for backwards compatible changes. So if you're currently on version 2 and you add a new feature that doesn't break existing clients, you bumped it up to 2.1. Finally, the patch version, which is the last number on the right, it's for backwards compatible bug fixes. So if a bug is found, someone submits a patch, makes it into master, makes it into release, you bump up the number on the right. So that would be 2.0.1. Now, the problem with using semantic versioning in APIs is that versioning services is different than versioning software. So if you have an old version of a software that's just sitting there, people can still use it, and it doesn't require your maintenance, right? You can simply say, end of life, I'm not going to be maintaining this anymore. However, when you're talking about a service, that service has to be running. If something happens to that service and you're still supporting an old version, you're going to have to stop what you're doing and fix that. So it requires a lot more work from the maintainers of an API to keep multiple versions working at the same time. So for versioning services, first thing that I recommend is only use major versions. That will help you, that will prevent you from bumping unnecessarily, from changing versions unnecessarily. If we talked about backwards compatible changes being added, why would we need to implement to bump a major version? All clients are supposed to still work because the changes that were added were compatible. So if you think about it, there's no need to update version 1 to version 2. Clients can still use that same version, as long as you follow the rules that changes cannot break existing clients. And that's where the effort needs to be. You need to make it so that any changes added to your API do not break existing clients. And a lot of them are actually backwards compatible. A lot of changes that I've seen that cause people to bump API versions can easily be rolled in existing versions. For example, the addition of a new format. If your current API supports JSON and now you want to add support for XML, why would you need to bump a version? If all the clients are already relying on having JSON, JSON's not going to be removed. You can still keep JSON there. The new clients that read about your API and see that you also support XML can write their clients for XML, but the existing ones don't have to change their code to support that new format. Same thing for the addition of a new property on a resource. If you're returning users with first name and last name, and now you want to add a full name property, why would you want to have to update your version for that? New clients can simply use that full name. Existing clients that don't know about it, don't care. They're not going to break. And lastly, renaming of an endpoint. HTTP gives us status codes for that. For example, the 300 class status code is all for redirection. But how about changes that break existing clients? How about if we remove a resource? How about if we get /users and completely remove it from our source code? Raise your hand if you think that breaks compatibility. Okay, 3 of you think. For the 3 of you that think that, I'll tell you one thing. HTTP status code 410, gone. How about now? I probably wouldn't go that far, but I recommend you check out this blog post by Mark Nottingham, and he argues that there's way more changes that are backwards compatible. And he does mention the removing of a resource, not necessarily requiring a version bump. You can simply use the HTTP 410 and say that a resource was gone. I think that's a little drastic, but food for thought. Now, lastly, I want to talk about tests. How to test your API. It's going to be real quick. First thing, testing APIs. Not the time or place for testing business logic. The core business logic of your application should be unit tested. Those are the tests that run fast, and they only focus on one specific thing. So what should we test in our APIs? Here's a couple of things that I think are really important. The status code, the Mimetypes, the formats, and authentication, rules of access. But if not unit testing, how should we test them? Requesting endpoints and verifying responses, so black box text, testing, which in Rails is integration tests, right? Let's look at an example of an integration test. For testing status code, so here we're using Minitest, which comes out of the box with Ruby. First thing we do is we make sure that our tests know that our API is under a namespace. So in this case, our API is under api.example.com. That's the subdomain. And for using a custom subdomain, we have to call the host bank method. And after we do that, we simply make a GET request to the endpoint and check the status code back. Check to make sure that it's successful. And if we really want to, we can make sure that the response body is not empty, right? Check there's something in there. Checking Mimetypes. Again, the setup is pretty similar. And what we do in this case is Rails, as the third argument for the test helpers in integration tests, is custom headers. So we can pass custom request headers as the third argument, and which is what we're doing here. For the first one, we're saying that the client accepts the Mimetype JSON. And then we check that the response is sent back as JSON. And then the same thing for XML. Now, lastly, how do we test access rules? We're going to use that same request header that we use for the token auth, which is the authorization you can see here on the right, passing in the token first. So in the first example, we're passing a valid token, checking that it's a 200 response, and we might or might not want to check also the mime time for this one. And then at the bottom, we're forcing a fake token and checking that it's a 401, not allowed. So lastly, I just want to mention one of our courses, go-to courses, that sort of talks about a couple of things that we talked about here. If you want to check it out, the first level is free. And I believe we have a couple minutes left for questions. So thank you very much. Any questions?
Yeah, you talked about some of the JSON or other format serialization techniques. Do any of those support deserialization?
Deserialization, I know that Roar does.
Okay.
So, yeah, I know that Roar does. But I've never accepted formats in my API that were not the default formats, either just JSON or XML. So if we're talking about formats like JSON API, that's usually returned from the server API, but not necessarily accepted by it. So what some APIs will do, they will just accept the plain old either JSON or XML, and then they'll respond with custom types. So, and Rails just automatically knows how to deserialize JSON. Yeah, so cool. Any other question? Yes, yes, absolutely. I will tweet this in just a bit. So that's my Twitter handle, Kaique, and I'll be tweeting this shortly. Don't be shy. I have stickers, so if that means something. Conference currency. So, good. Yeah, what's up? Yes. Validate the format or just validate authentication? Okay, well, on that example, I just generated the token, stored it on a property on the user's model, and then whenever it was sent on a request, I would just match that to whatever's on the database. So, yeah, simple stuff. You can definitely get more secure depending on the context. You know, you can store it on a different table, or you can hash it, do whatever you want. So, cool. Any other question? All right, I'll be around here, so if anyone has any other questions, come to talk to me. So thank you very much again.